Hi guys and girls on YouTube, and welcome to my channel. In this video we're going to be taking a look at a little 14-inch portable TV. This could have been the best-selling TV of the 1990s. And the reason it was one of the best-selling TVs is because it was so cheap. Now this is actually a Saisho, and if we turn around to the back, the model number is a CT141X. There was an identical one wearing the name Matsui, and I think the model number was 1420A off the top of my head, which was exactly the same telly, but one brand was sold by Dixon's and one brand was sold by Curry's, and one of these was actually £10 dearer than the other. Even though we were buying exactly the same set with a different name on the front. So what I'm going to do is I'm going to search out for the service manual first, and then we'll just take the back off and have a quick look inside. Right, so I actually found that quicker than what I thought. Let's take a quick look through here. We've got handwritten notes on the front. I've also got see, this is when Curry's and Dixon's used to be Mastercare service. They used to supply spare parts, and as a dealer you could order spare parts and do things yourself, but you won't get any parts from Dixon's or Curry's now. That's all gone. So let's just have a look here. That's 1455. Yeah, that's the one there. CT141X, so it was the same as a Matsui 1420. Let's just put that to one side. Let's have a quick look here, see what else I've got. Triumph, don't know what that one is. Oh, another Matsui. What's the date on that? 1987. So the telly we're looking at, it could be earlier than the 90s. I can't remember now, it's such a long time ago. Video recorder, Hinari video, Matsui video player, more Hinari VXL5, some handwritten notes here. As you can see, my spelling's not that good, never has been. Right, so we've actually got the service manual that we need to look at this set. Now, what do I remember about this set? Well, the most common fault was the power supply IC. I think it was an STR. Was it STR 50103A? And that used to go short circuit, and it used to take out, I think it was a 5.6 ohm resistor. And the fuse never actually blew, it always blew the resistor. And we had a standing joke in the trade. What is the resistor actually for? Well, it was there to protect the fuse and stop the fuse blowing. Right, so let's have a look here. As you can see, it also covers the Matsui 1420A. We've got parts listings. Every part was available as a spare part, unlike today. Let's just have a look there. Oh, part number for the PCB, technical training. That's another thing you don't see these days. These are all parts listings. Let's just get to the diagram. Cabinet parts, you see, all available. Every single nut, bolt and screw was available as a spare part. Right, so we're coming to the diagram here. Oh look, more handwritten notes. Right, let's have a quick look at the power supply. Right, so that's the signals and IF and tube base. The power supply is actually on this other page here. Got some more handwritten notes there, see, I'd forgotten about that. There was an SR2 avalanche diode, that used to go as well. Now, interesting enough, it says here the switching regulators STR451. I think they could be fitted with different variants, and it does say there or equivalent, because the one I clearly remember was an STR CT141X, which is made by Sank and a 5-pin device. This STR451 is a TO3 3-pin device. But if we look at the very simple power supply, that's it, that chopper transistor there, one rectifier, that's the input bridge, and if you look, there's a 5.6 ohm resistors, yeah, so I got that right, and that was there to protect this fuse and stop this fuse blowing, because the fuse never ever blew. Right, so I think the best thing we can do now is get the back off the TV and have a look whether it is fitted with what it says here or what I think was in. Right, now interestingly enough, this supplement's just dropped out, and if we look, it's the same set, but this is fitted with yeah, STR50103A. So we could have either one fitted, and we don't know till we get the back off. But I seem to remember though, these were such a regular failure. I've got it in my head that at one time they were supplied with a different heatsink compound. I'm sure they were supplied with a blue heatsink compound, and they tried to say that was the reason for the failure, because you needed this special heatsink compound, but of course it actually did nothing at all. It was nothing more than the gimmick. It's actually the Sanken device that had a problem. Right, so take a look at the back. You've got an isolated aerial socket, which incidentally I've just noticed the middle pin's broke. You've only got a headphone socket, no SCART, no AVs. I don't think SCART was invented actually when this set came out, but just 4 screws to take the back off, and then we'll have a look. Right, so that's the back unscrewed. I'll just mention, I think most of these cheap sets back in the day originated from the Orion factory, which you'll see when we get the back off. The Orion made for lots of different people. Amstrad was another one they made for. But I will just mention, if you look at this, this is the proper service manual from Mastercare. They all came very, very poorly photocopied. It's like they only had one service manual, and they were running copies off to order as people ordered them. But if you look at that, the photocopying is actually very, very poor. And some of these diagrams are a little bit difficult to read. But anyway, let's get the back off. So the first thing we do is pull that. We've got to unplug the aerial wire from the tuner, which is down there. Right, so that's the back off view. What we need to do is unplug the speaker there. Very, very tight. And then slide out the chassis. But first, before we take out the chassis, because I can't just see yet what kind of power supply IC it's fitted with, let's talk about something that is really, really important. That's the Orion tube. And you need to attend to this before you even think about plugging one of these in. And we're talking about these wedges for the convergence and purity. What you need to do is you need to check that rubber, and if it's gone hard like that, you've got to take these out and cover them with some tape and put them back in. And the reason for that, I think there's 3 wedges, there should be one. Yeah, there's one under there and one there. These over time underwent a chemical change and they become hygroscopic, they absorb moisture. And because this is in contact, that's the frame scan, the line scan is on the middle, these rubbers are in contact with the line scan coils, and what happens, because these absorb moisture, you've got moisture sitting on your coil windings, and you'll end up with shorter turns in the coils, and then it's completely ruined unless you've got another set of scan coils. It was a very, very common fault that back in its day. In fact, I actually wrote an article in Television Magazine about it, and if we zoom in there, you can see where the scan coil the rubber wedge actually touches on this metal frame of the scan assembly, and we can see rust appearing there. But these are hard as rock. They've got a shiny, wet appearance to them. So we're definitely going to have to take them out before we even plug it in, because you could end up writing this set off before we've even started powering it up. Now, just to prove the point, what I'm telling you about, let's take an ohm meter and let's put one prod there into the rubber. Let's put another prod, if I can do this with one hand, there. And look at that, we've got electrically conductive path in the rubber. So if I move to a different place, let's move to there. So that rubber is a time bomb ticking away. So before we plug this in, I'm going to take these out. If you take them out one by one, you'll have minimal purity or convergence adjustment when you come to put them back. Right, now that's the offending rubber out, or one of them at least. If we take a good look at this, you can actually see droplets of moisture sitting on the surface there. And that is caused by the rubber going hygroscopic. Now that is, at one time, if I'd scrapped an old telly, I used to always keep these rubbers, but when I ran out of rubbers, I just used to wrap them with some PVC insulation tape and fit these back in. But what you don't want is, you don't want that rubber in contact with the scan coils, because it eats through the enamel. And you'll get a shorted turn. You either get no pitch, or you'll get like a trapezio distortion on the picture. But you can see there, let's just give it a wipe with my finger. Yeah, moisture. Right, so they've got to be out. Now, of course, I don't have any of these rubber wedges anymore, but back in the 90s, when I'd run out of them, what I used to do is I used to wrap them with some black insulation tape and just fit them back in, because as long as the absorbing surface doesn't come into contact with the line scan, they should be alright. And I did that quite often and never had a comeback. So this is what I used to do: take a bit of black insulation tape, put your rubber on it, and we need to be covering up the side that comes into contact with the scan coil, which is this surface here. So if I put that on there face down like that, right, like that, and that is the surface that touches the line scan. So you can just see we just put a bit of tape around it, and now you just wedge it back in. It's got to be in exactly the same place, otherwise we'll alter the purity and the convergence, but we can sort that out when they're all done, or when the set comes on we can sort that last. Now these of course will need adjusting, because what they do is they tilt this yoke. So once you've adjusted them, you put a dab of silicone on and you put some tape over there to hold it in the final position. But just for the purpose of this video, I'm just going to leave them loose. So now we just got the other two to do, this one and the one under here. That's the other one out. As you can see, that is also wet, just there. Right, so with that attended to, all we need to do now is pull off these knobs, and then there's one single screw inside, and the chassis should slide out, and the screw is right down there at the front. Right, so that's the chassis out. If we take a good look at it, that there is the audio isolating transformer, because this of course is a live chassis. And if we just move over into the back, you've got your isolation components there, in the aerial socket. So always remember that. I mean, it doesn't matter to me because I'm working here with an isolation transformer on these benches, so I can plug an aerial straight in there. But if you're doing this at home, you must use the aerial isolator or an isolation transformer. But let's take, I mean, don't forget, back in the days things like this were considered to be crap, but if you actually look at the construction, it's very, very nice. That is your line output transistor there, 2SD1397. That appears to be the original line output transformer. Let's have a look what chip we've got. So we do have the STR50103. Now I wonder, by the amount of heatsink compound on there, if somebody's already changed that. Let's have a look. That is the 5.6 ohm resistor, which I pointed out is there to protect this fuse and stop the fuse from being damaged when the STR goes short circuit. Well, that's what we used to say in the trade anyway. That's the 2-pin degaussing resistor. I've no doubt all these controls will be noisy, but you can just spray a bit of cleaner in. Likewise, the channel change will be noisy. Let's just run over here, and then we'll take a look at the other side and see if anything's been done to this. I mean, it might even work. I don't actually know. That's a little chopper transformer there, and the main HT reservoir capacity. That's the frame output. What will that be? UPC 1378 off the top of my head. Yeah, UPC 1378H. Most of these parts I'll still have in stock. So let's flip it over. That's where the scan coil plugs in there. Let's flip it over and have a look if anybody's done any work on this. In fact, it tells you in there, look, warning, live chassis. Oh, let's have a quick look at the tube base, red, green, blue output. You've got controls for blue and red. Right, so it's very nice looking underneath. I can't see any work at all been done to this, so there's a good possibility this will just work. But what I'm going to do first is I'm going to check that 5.6 ohm resistor, the avalanche diode. If either of them are faulty, that points to you definitely have to change the STR. But apart from that, it's all in good condition. The only area of interest I can see concerns the line driver transformer, which is there. It'd be a good idea to solder them, and also the collector feed resistor for the transistor. That gets very hot, as you can see, and it does appear to be dry jointed. So I'm just going to solder up them dry joints and the transformer for good measure. I might even solder the frame output IC, and there's a little 3-terminal regulator there. Just solder that for good measure, and then I think we might just go straight for the plug-in, see what happens. Right, so that there is the line driver transformer we're going to be resoldering. That's the line driver transistor, the collector feed resistors. Them 2 transistors there, those are the sound output feeding this little transformer. Now, did that move when I touched it? No, but I think I'm going to resolder it anyway. Right, so the surge limiting resistor's okay. That measures alright. The avalanche diode is that funny little coffin shaped diode down there. SR2M, I think, is its number, which is basically just 140 volt Zener diode, which is just meant to go short circuit in the event of the output rail rising above 140 volt. I think from memory the HT rail on these should be about 112 volt, but we'll check that in the manual. I'll just check the diode next. The resistor's okay. Just check that diode, then we go for the plug-in, see what happens. Right, so that's just resoldered the line driver transformer and the collector feed resistor. I think we're all good to go now. In fact, what I'll do, just in case it does come on, I'll give a quick squirt in these pots with some service hole. Just in that little hole there, then just wind it backwards and forwards a bit and do that for all four. Right, so I'll just let it stand a while with the main HT reservoir cap reforming, and then we'll put the chassis back in and we'll go straight for the switch on. So the cap's reformed. I've just put a bit of foam cleaner on there before I put the knobs back on, just because it's a little dirty. Right, so that's it, we're nearly ready to go. Unfortunately the tuning door's missing, but I might come across one day. That there's the automatic frequency control manual on and off switch. I can't remember whether that's manual or it's operated actually by the door. I think it's manual rather than door operated, because when you push it in it stays in. If you look there, we've got a position for a video recorder. So let's just make sure the volume's not too high. Let's just go straight for the switch on now and see what happens. I think what I'll do is I'll turn it on there, and then I'll fire it up here. I'll just stand back. Here we go. 3, 2, 1. Well, that's a good sign. It's lit up. Oh, we've got a raster. And we've got sound. Right, so we have a working set. But just let me show you this for those who don't know. I know to most people this will be obvious. To some people it won't. Before we connect it up to a signal, I'm just going to unscrew that. That's it, just take the aerial isolate off. Back in the day when I used to repair these, I just used one of these from a scrap set. I never bothered unscrewing them from the telly. And unless you've got an isolated transformer, you must do this for safety, otherwise you'll blow the setup. Plug into there, and then we can plug the aerial into there. Right, let's get a signal source to this then. Right, so that's it. I've connected the aerial to a skybox. We'll switch on, probably select position 1 and tune it. Oh, it's already tuned in.
Horse number 8. They're all going to be loaded late. They've got a little bit of previous.
Right, so position number 1's tuned into a skybox. The output of the skybox is channel 36. No, not 36. The output in the skybox is channel 68, which they all came on. They all came as standard, set to channel 68 in the RF modulator. So that's a pretty good indication that somebody has already used this with a skybox. I don't know when. I don't know when the last time this was on. If we turn the colour down, it's a bit green, so we need to adjust the grayscale. Yeah, you can see it's green there. That's brightness, contrast, cracking picture, but you know, the condition it's in inside, I would have expected that really. So let's just adjust that grayscale and get it back to a black and white picture. Right, so just turn the skybox onto colour bars. There we go. And you can see now it's a bit green. Let's just turn the volume down. Now there is of course no adjustment for the green, so we're just going to lift the blue to compensate and get that back to a black and white picture. So there it's green, we can make it blue. And that is probably as good as it gets. It still might look a little bit blue on the camera, but we've actually got a black and white picture now. Let's put the skybox back to colour bars. Not colour bars, back to the picture. Lift the colour up. That's better. Focusing's pin sharp.
Good job.
I can't see them so well.
Yeah, a very, very nice set that. And as you can see, the rubber wedges haven't done any damage to the scan coils. Right, so just one last job to do. I might have mentioned the scan coil wedges, they actually alter the purity. So what we need to do is we need to put it on the red background and make sure there's no purity errors in the picture. So here we go, and if you look at that, ignoring the black band coming to the camera, the purity is absolutely spot on. If it wasn't, we'd have like different coloured patches other than red in certain places. So we've actually got the wedges back in exactly the right place, and they're just ready to be glued back in place now so they don't move. Now this is actually a little bit over exaggerated, but for those who don't know, when you alter the wedges, if you look at that, we've got a purity error there. We haven't got red, we've got a different colour, but that's well over exaggerated. In fact, I've just remembered, I'll just mention this, something else I've just remembered from back in its day. There were a couple of 330k resistors that used to make the set go dead with no other faults. Let's have a look. Oh, there they are. So they come straight off the reservoir capacitor and then straight into that chip. We used to call them the startup resistors. They were always going open circuit, but I mean, look at that, what a set that is. Let's just see if we got a better channel to look at. Oh, actually it's not too bad now.
Here's the sheet Murphy winning again at this Royal meeting, number 4 for him. And well done to Nicola Dowell, who I think rides Cardham out each day.
And the thing to note, back in its day, these were considered poor quality. I'm sure they were about £30 cheaper than buying a branded make. But look how that stood the test of time. And if you compare that with sets of today, flat screen tellies that are only lasting 18 months and then they scrap, the tables have turned. Poor quality in its day. Now it's a fantastic TV. But yeah, there we go, guys and girls. Many thanks for watching my video. I hope you've enjoyed it, and I'll catch you in the next one.
It was a great run from Swing Along. It was on that strong gallop every step of the way. They were doing over 40 miles an hour, but Kadina's backed it up with a second win in this race. Shadeen, Cardham.
Alright, goodbye, many thanks for watching.